All right, so new unit, we're talking about your mathematical models. You're going to be seeing things like functions, quadratics, exponential, logarithmic functions, cubics, quartics, etc., etc. All that is under this unit. So some of these things you will have remembered from Algebra 2. Other things, might be new to you, okay? But we're talking about functions today, and you got to be able to determine what is a function, how to graph different functions, as well as determine domains and ranges. So, to start off, a relation. Hopefully you guys remember that a relation is a set of any ordered pairs, okay? So, there's an example up there for you. A equals curly bracket, that's what represents a set. And then you have the ordered pairs within that set. And then in curly bracket, okay? And a function is a relationship between two sets, okay? You have your first set, which is your x values, also known as your input. And then you have a second set, your y values, which is known as your output. These words, function, relation, input, output, sound familiar? Yes, no, maybe, or y'all too busy writing that you're not hearing what I'm saying right now?
Not really. I remember saying something.
Okay? Make sure that you are not just mindlessly copying it down, but you're also listening, okay? And I go through every single line, so that way it's kind of like, okay, hey, she said that, let me fill that in. You listen. She said the next thing, let me fill that in. You listen, type thing, okay? But the main thing with a function is that each x is related to one and only one y. Maybe you've heard there's one input for every output. Maybe you've heard those two things, but that basically is what makes something a function versus what makes something just a relation. Okay? So, you have an example. Antonio and Lola are students at Green Village High School. And Mew is a student at Japan High School. The set of students, A, is represented by the set Antonio, Lola, and Mew. The set of schools represents set B, and you have the abbreviations there. We have to decide whether these relationships are functions, and we're going to justify our decisions, which means we're going to either explain in words why it's a function, why it's not a function, or we're going to show in some other type of way. So we're looking at the relationship between the first set A and the second set B, as X is a student at Y school. So our input represents what? The student. Remember, X is related to input, so we're students, and our output is the schools, okay? Is that a function? Is there an X from one and only one Y?
Yes.
Does one student attend two different schools? No. Okay, so you have Antonio, he attends, what is this? JVHS. And you have Lola, she also attends that school. And then you have you who attends the other school. Now, one way that you can actually look at a function besides looking at it as a set of ordered pairs, you can actually look at it as a mapping diagram, which is what I'm drawing out here. You have two circles, one circle representing your inputs, one circle representing your outputs, okay? And you use arrows to show what each input goes towards. So Antonio, he's a student at GVHS, and Lola is also a student there. As we notice, there's one input for one and only one output. And of course, Mew goes to Japan High School. That right there is a mapping diagram. That's another way they can represent a set of points, okay? Now, B is the relationship between sets. The first set, which is going to be B in this case, and the second set, which is going to be A. So X this time, the input is the school, and Y is the student. Is that a function? No, it isn't. If you want, you can actually draw another mapping diagram. You have the schools this time as your input, and you have the students as the output. JDHS is going to have two arrows coming from it, isn't it? And this right here does not hold it to, there's X, there's only one and only one Y for each X. You see that? This time, with this being your inputs and outputs, B is an example of it not being a function, but A is a function. And if we want to explain this in words, we can say there's one output for every input. And then we say the opposite for this one. Questions on that?
So basically, you just have to draw graphs.
Drawing a mapping diagram is an example of showing if something is a function or not. Sometimes they might be listed in tables instead. Sometimes they might be listed in like that set notation that you saw on the previous slide. But it's just another way to pictorially see it. Okay? But the one thing is that you do not want to have an X value that has two different Y values. That's the main thing. Other questions? Let's look at this one. I'll do one of these with you. You do the other two on your own. It says let A equal the set of these numbers 1, -1, 0, 2, and 4. B is 1, 0, 4, and C is 1, 0, 4, and 16. We have to decide whether these relationships are functions, and we're going to justify our decision. The relationship between the first set A and the second set B, and we're given this stipulation. The square of X is Y, or here in this Y equals X squared. Okay? Our input is which set? A or B? Is A. And our second set, our output is B. Okay? So our X is A, and our Y is B for this very first example. Okay? I'm going to show you it another way. Yes, you could do a mapping diagram. Yes, but I'm going to try to show you, as many ways as I can think of to represent this, okay? Let's see. For A, we have 1, -1, 0, 2, and 4. Okay? And for my Y's, which are technically going to be my B, and these kind of also fit into the stipulation of Y equals X squared. We are given that. If I plug this in, 1 squared, what is that? Is that a part of the set B?
Yeah.
Yes, it is. So far, so good. -1. What's -1 squared? 1. Is that a part of set B? So far, so good. We got to make sure that when we're plugging these in, that the numbers that we get are a part of set B. Okay? Plug in 0 with 0 squared. Is it in the set? 2 squared. 4 is in the set. 4 squared. 16, is that in the set? No. 16 is not in set B. Is this a function? And then that will be the justification of that. I want you guys to do B and C. You could do it using a table, you could do it using a mapping diagram, your choice. Alright, so the relationship between the first set A and the second set C. We're still dealing with Y equals X squared, but this time we are comparing our input is what set?
A.
And our output should give us a set that's within C. So when you guys did it, raise your hand if some of you guys might have just looked at it and was able to tell. Who did a table? Anybody do a mapping diagram? Okay? Either way, we should still get it. Okay? Using the table concepts, we are plugging in 1, -1, 0, 2, and 4. And when we plug it in, we get those results 1, 1, 0, 4, and 16. Are all these numbers inside of set C? Yes, and even though ones repeat, that's fine. Okay, it's fine if the ones repeat, because technically you're not going to put multiple ones in a set. One is just represented. So yes. Okay? And of course there is one output for every input. What about the last one? This time was different. It was the square root of x. What represents your input?
C.
And your output?
A.
So when you plugged in, you were plugging in 1, 0, 4, and 16, all of them perfect squares of square root of 1, 0, and was this all numbers in set A? Yes.
No, it just has to be in. It doesn't have to be all.
No, yeah, you just gotta make sure all the numbers we're looking for
Are in the set, yeah.
you don't have to fill out the set.
Questions? So far, are we okay on functions?
I never get. I guess the doctors are adding stuff.
Okay. Here we go. Domain and range. We dealt with domain already when we were talking about composite functions and things like that.
I see it.
And we're going to go a little bit into range. You guys also did this back in your Algebra 1, Algebra 2 days. But, of course, the first set is called the domain of the function. So that means your x values. Okay? Those make up your domain. X values are also thought of as your independent variable. Okay? For each value of your x, your input, there is one and only one output, like I've been saying, to make it a function. Now those values that are in your output can also be called the image of x, okay? So image is just another word for output. Now the set of all the images, all the outputs, is called the range of the function. The elements of your range are your dependent variables. And a lot of times when you're looking at functions, that is your y variable. But realize that x and y, those can actually be different. Okay, you just have to recognize what is your input, what's your output, and then those will be your independent and dependent variables. Questions on that? Moving forward. When finding the domain algebraically, you need to be concerned with two things. When you have a division by 0, okay? This occurs when you have what's known as a rational function, when you have a variable in your denominator. So something like this is an example where you gotta make sure that you can't have 0 in the denominator and make it undefined. You also need to be concerned with taking the square root of a negative number. Because when you take the square root of a negative number, what happens? You get an error message on your calculator for sure, because it's going to be a, what type of number? Imaginary number. An imaginary number. So if you have something like this, you have to be aware of, because normally, the domain of any function that you're going to be getting, normally, like 98% of the time, the domain is going to be all real numbers. Okay? However, if there's a restriction, like in one of these two cases, when you have a 0, when you could have a 0 in the denominator or a negative on the square root, you do got to make sure you state those restrictions. Okay? And there is a way to represent all real numbers instead of just putting the words all real numbers. What is the symbol to represent all real numbers? It is the R with the double bar. Okay? So do not forget about that from your number and algebra. Questions?
That's real.
Real. So, some of these. Very simple, very basic. However, I don't want to complicate it any. Consider the function y equals x squared. Find the image of x equals 1. Image means what? No? What does image mean? What type of value? Huh? The dependent variable. So basically, we were trying to find the dependent variable value for y. So we're going to plug in 1. What's 1 squared? So our image is 1. And what is it when we plug in -2? your instincts that you know that negative 2 squared is a positive 4, you're going to type into your calculator to try to confirm it. Air quotes are going on right now. And then you'll do this and you'll say, my calculator's broken. No, no, no. It's just you. Okay? Plug it in there. Now you got your positive 4. Okay? Just to put that up. Now you have to write down the domain of this. X squared. Do I have a denominator anywhere? Am I taking the square root of anything anywhere? So if it's not one of those two stipulations, then I know my domain is what? All real numbers. Now, to write that, did I go over set notation with you guys already? It would have been in unit 1 if anything. No. Perfect. Set notation is one way to represent domain as well as range. Okay? Set notation consists of curly brackets. The variable in which you are trying to represent. So in this case, we're trying to find our domain. So domain is related to what variable? X. Okay? You have a bar. You always do the variable that you're trying to represent, X, the bar, and then you actually put in whatever the domain is. In our case, since the domain is all real numbers, then X is an element of all real numbers. The curly brackets are read as the set of this here. Of course, it's going to be X values. The bar such that. And then, of course, this right here is whatever the domain is. And in this case, since X is all real numbers, X is the element of all real numbers. So even though, yes, that is your answer, it's read as the set of X values such that X is the element of all real numbers. Questions on that? How it's written? Okay. If I was talking about the range, which I'm going to do in part C, you're going to change X to what? You're going to change X to Y. Okay? So set notation is one way to represent domain. Another way to represent is interval notation. All these things should sound familiar if you passed through Algebra 2. Raise your hand if you did not take Algebra 2. Okay, well then that is the second. Everybody else though. You should definitely have seen these two. We covered these in Algebra 2. Interval notation is when you have the parentheses or the square brackets. You guys remember that? It can either be like this or like this. Could be a mix, depending. Look familiar? And you read from left to right. We're talking about all real numbers. That goes from what number to what number? Negative infinity to positive infinity. Because it includes all your negative values as well as your positive ones. So you can also represent all real numbers in interval notation. You never put square brackets around infinities. Never. Okay? Why? Because the square brackets basically means that that number is included, meaning that it stops at that number. And the thing is that infinity doesn't have a stopping point. It keeps going on forever and ever. So if there's no end point, there can never be a stopping point. Meaning there can never be a square bracket. Make sense? Now we gotta write our range. Our range relates to our Y values. Now the beauty of this class, the beauty of studies, is you get to use your calculator. Okay? So if you ever have a question about what the domain is, or what the range is, you can always graph it and look at the graph. So everybody pull out their calculator. I want you to graph this function. How do I graph this function? Y equals x squared. Where do I go?
Table. Second table.
What?
Where we go?
No, I'm trying to graph this.
The graph button.
I gotta go to y equals first. Because I gotta put the function in, don't I?
Yeah.
If we don't, it's not gonna give us anything, or it's gonna give us whatever's sitting in our calculator. So I gotta type in my function. It's gotta be x squared. X is located where?
It's next to it's right under mode.
under mode next to alpha, and then I have to square this. How do I type in a square? I'm making zero assumptions. There's an x squared button. It's located where?
On the far left under X minus 1.
Three from alpha, diagonally from the 7. There we go. Types in a nice little square for you. Okay? And now I go to graph. See what my calculator said. Okay, there we go.
Hey,
What do you think happens above positive 10? What do you think happens?
it keeps going.
Keeps going up, right? Okay. So my range relates to my outputs, my y values. My y values look like they're defined in a general region, but not for all real numbers. And when you read your range, you read from bottom to top, just like you read your domain from left to right. What is the lowest y value on this graph? 0. Is 0 defined? Like, do you think there's an open circle at 0? Like making it undefined?
No, it's a bracket because it stops.
It is going to be a bracket there. So we're starting at 0, we're going all the way into what?
Infinity.
Infinity. So our range is going to be, if we're writing it in interval notation, 0 to infinity,
So one bracket and then a little curly thing. Parentheses.
a parenthesis. A bracket around the 0 and a parenthesis around the infinity.
Plus minus.
If I were to write it in set notation, I'm going to have the set of,
Last number.
what variable am I putting? Am I putting x? Putting y. Such that, now to represent this part, we're not going to put an interval notation inside of a set notation. They don't go together. We're going to basically write the inequality equivalent to that. Inequalities, that's greater than, less than, equal to, all that good stuff. I'm trying to represent all the values that are clearly what? How would you represent this as an inequality? Say again? Greater than 0? Is it equal to 0 as well? Yes. So it's going to be the y values that are greater than or equal to 0. That's how you represent that in set notation. All right. So again, with the interval notation, the reason why it's a square bracket here is because 0 is included. Like 0 is a starting point for us in our range. When we look at that graph, it's defined at 0.
Kind of like on a plot.
Exactly. So if it was on a number line, it would have been a closed circle at 0 and then everything bigger than that. The only time is if it was ever an open circle, then you have a parenthesis. And the reason why it's a parenthesis around infinity, again, that's not a defined number. Like at no point in time will it ever stop anywhere.
So basically, a parentheses are like symbols.
They're like what?
Symbols, like a symbol and something.
The parenthesis symbolizes that that number is not included. Bracket means that it is included within the range. All right. Look at this example. We're going to consider the function y equals 1 over x, and x does not equal 0. Okay? Anytime a problem gives you something like that, it's just making you aware that, hey, x cannot equal 0, so don't be trying to go and plug in 0 at any point in time. Okay? Please make sure you write this in. It is not on your paper. It is the next example, but this is one of those that didn't get transferred over. First question says, find the image of x equals 2 and x equals negative 1/2. That basically means just to do what?
Funded. What we did before.
Do what we did before. Plug it in. Y equals what when you plug in 2? 0.50 or 1/2. Awesome. What do we get when we plug in a negative 1/2? A negative. What? So, when you're finding the image, you're looking for the y. That's what you're looking for. So you're basically taking each of these x's and plugging it in. So when you plug in x here, it's going to be 1 over 2. So that's your answer. Here's your other x value. You're going to plug it in. It's going to be 1 over a negative 1/2. You're plugging that value in. And now I'm asking, now you can't leave it like this. And never in your life of math can you ever leave a fraction within a fraction. You have to simplify this. Yes?
-2.
It is -2. All right? You guys are allowed to use a calculator the entire time, so if you need to, type that in. 1 divided by a negative 1/2, and you'll get your answer. And the reason why it's -2, bless you, you might have learned about this concept a long time ago of keep, change, flip. Does that sound familiar?
I've always told if I could never memorize it.
Consecutive.
Keeping the first number. What does C stand for? Change what? The sign of division to what? And then flip the bottom. Negative 1/2, when you flip it, turns into a what? -2 over 1, which is a -2. That's where -2 comes from. That's how the calculator will figure out that it's a -2. Okay? Now we have to write down the domain. Normally the domain is all real numbers, but
This can't be 0.
this one can't be 0. So the domain is going to be all real numbers except 0. How do you write that? Well, interval notation, I don't like writing it in interval notation with this restriction. But I will show it. An interval is everything but 0. So if you think about it on a number line sense, okay, it's all of this except 0. What number is all the way to the left?
Negative.
Negative infinity. And it goes all the way until what number?
Negative.
0. 0's not included, so we have to stop there. What's going to go around the 0? It's a parenthesis because it's not included at 0. It's undefined at 0. If I plug 0 in, I want to get an error message. Any number that gives me an error message is not what I want. So we always put parentheses whenever that happens. But after 0, I go into what? Infinity. And you connect the two using a union. This should look familiar from algebra 2. Even from algebra 1 is looking too.
I passed this test in this class.
I feel.
Okay?
It's like the only test I passed.
Because the U connects the two. Connects the two domains. Anytime you have a domain that's broken up, like it is here, you connect it with the U. The U just means union, also, as well. So not just negative infinity 0, but also 0 to infinity. Alright? I don't like writing these like this, because I think set notation is so much better. The reason why I say that is because set notation, of course, we have our curly bracket. We're talking about domains, so we're going to have what value? Or what variable? X, such that to represent that it's all real numbers but 0, all I have to do is X does not equal 0. Alright, and I'm done. So basically, what was given to me originally, I just have to make sure I include the proper notation along with it. That's why I like set a lot better than interval. Next on that. C. It says decide whether y equals 0 is an element of the range and justify your decision. To determine this out, basically, plug in 0 for y and solve for x. Just think about it. If it is a part of the range, that means there should be an x value that goes along with it. Okay? So plug it in. I have y equals 1 over x, so 0 equals 1 over x. Solve for x. What do you get? 0. Like x equals 0? You get 0 equals 1 because you'll end up doing what to get x out of the denominator?
Or multiplying it.
What's x times 0? Yeah, 0 equals 1. Can you have something like that? No. So no, y is not an element. justify your decision, well, this work of showing why it doesn't work is enough to justify. Do part 2. Decide whether negative 5 is an element. Can you guys do that one? Well, is it? Yes? You guys got an x value when you plugged in negative 5?
Yes.
What was the x value? Negative 1 over 5. If it wasn't a part of the range, then you would have gotten something like what we got for part C, I. Okay? But because we actually get a value, that means that's a point. Negative 1/5, comma negative 5, that's a point on this graph. That's a part of the range. Questions? All right. Drawing graphs. All the way back to algebra 1. If you ever forgot how to graph something, what did your teacher tell you to do? Huh? And then she might have told you to do what? Besides that. Anybody else? Like if there was a special way to graph like a quadratic or a line or whatever. Say again? Use a table. Make an XY table. Y'all remember doing something like this? Plugging in values for X and getting Y's and just plotting the points? You can always do that. Okay? But that's like the last resort if you forget how to do any of this. But this is a line, guys. Negative x plus 1. And more specifically, it's a line that's in the form y equals mx plus b. Where m is what? The slope. And what number is that? Say it again. Negative 1. And then the b represents what? The y-intercept, which is what number? 1. Whenever it's in slope-intercept form, that's always the best way because the point of where the graph crosses the y-axis, which is 1, is a point on your line. And then remember, you just go from that point and apply the slope. If the slope is negative 1, I go from that point and I go down 1, right 1. And I do it again. Down 1, right 1. Down 1, right 1. You guys remember doing this? I could also go the other way to get points along this side. From that original point, I could go up 1, left 1. The reverse. Up 1, left 1. And then try to draw the straightest line possible. You guys remember doing this? Yes. And you can also just input into your calculator. Okay, and then just copy exactly what's on the screen onto your paper, making sure you're crossing the x-axis and the y-axis at the right place. Speaking of, you have to write down the coordinates of where the graph of this function intercepts the x-axis, aka the x-intercept. It's a point. Make sure you write it as such. What's that point right there?
1, 0.
Is it 0, 1, or 1, 0?
1, 0.
1, 0. Because we're 1 over on our x-axis, but we didn't go up or down any. Where's it cross our y-axis?
0, 1.
0, 1. How do you figure that out algebraically? Not quite. Or plug what in exactly? Plug in 0, yes. But for what? I'm trying to find my x-intercept. I'm going to put 0 in for y. Because I'm trying to solve for x. If I'm trying to find my y-intercept, I plug in 0 for x. You ever had to do it algebraically? Or if you ever had to show why something is an x-intercept or show why something is a y-intercept, you would need to algebraically do those things. How do I know if a 200 and negative 199 is actually on the graph of this function. Yes?
Well, if you put it into your calculator, then you can go into table set, select table start to be 200, and then just go table. And it'll show you what it is.
I can type in that function of negative x plus 1. I can change my table settings to start at 200, and then I can actually look at my table. And yes, it is negative 199. Another way you could have done that is you could have looked at the graph. You could have gone to second trace and did option 1 value and typed in 200. Oh, I gotta actually open up my window to be 200. So I started to change a window setting. Okay, let's take this back. Window. Here we go. Could do it that way as well. Or, what do you think? What's the algebraic way to figure this out? Plug 200 in for x and see if you get negative 199 for y. Negative 200 plus 1? It is negative 199. That's actually what you will have to do for part C. Because in this case, we don't have a y value. You could go and look at your table and go to where x is 6 and see what the y value is for there. You can definitely do that. Or we can plug in 6 for x and find out that our y value is what? Is what? Positive or negative?
Negative 5.
Questions on this? I want you guys to give this one a try. So remember, when finding your domain, the domain relates to your x value. So if you're looking at a graph, you're trying to figure out, okay, how far left and how far right does this graph actually go? And then you want to look at those numbers. This here indicates that this graph keeps going, keeps getting bigger and bigger, getting wider and wider, which means the furthest left this graph is going to go is what?
Negative infinity.
Negative infinity. And we can see in the graph that there's a point there, meaning that it stops, so the furthest right it can go is
3.
positive 3.
I have that.
So, if you wanted to write this in interval notation, which I saw a lot of you guys do, if you're trying to go from negative infinity to positive 3, what's going to be around the negative infinity? And around the 3?
Bracket.
Because it is a closed circle, meaning that it's defined at 3. 3 is a part of this. If you wanted to write it in sets, I'm basically looking at this, okay, it's from negative infinity to positive 3. That means it's everything that is less than or equal to 3. So it would have been written as the set of x values such that x is less than or equal to 3. Questions? Your range is the opposite. Instead of going from left to right, you're going to go from the bottom to the top. What's the lowest that this graph goes? What's the highest that it goes? What's the lowest it goes? Negative 4. What's the highest that it goes? Infinity. You know that. There's an arrow there indicating that. And a lot of times, guys, if there isn't an arrow, it usually means that it keeps going. And if it's stopping, tell you usually say it somewhere in like the directions of the problem. That is only going from this value to this value. What's around -4?
Bracket.
And around infinity? Or if I wanted to write that in set notation, it would be the y value such that what? If I'm trying to go from -4 to infinity, that's basically going to be everything greater than or equal to -4. See, I should have been simple enough. We have the graph there. What are the points of the x where it intersects the x-axis? 2, 0. And what? Other way around. -2, 0. X-axis. Not 0 first. 0 second. What about the y-axis? 0, -4. Easy enough to see on the graph. Questions? Function notation. Y equals f of x. You've seen f of x before, yes? Okay? It's not always just f of x. Sometimes it's v of x, or s of t, or g of x, or whatever. The main thing you have to realize when it's in notation like this is that whatever's on the inside of your parentheses is your input, and then the whole expression is your output. So basically, whatever number I plug in for x is going to give me a solution, and I plug that number in to every variable I see in my problem. So in this case, when I actually find the image of x equals -2, yes?
Isn't f of x like y?
Exactly. F of x is basically saying y. But the thing is that x is that input, and then f of x is that full output. It's like whatever you do when you plug it in. Okay. So, find the image of x equals -2. That means you're going to plug in -2 for x. Everywhere you see an x. And then you just simplify it to figure out what's that y value. When x is -2, y is what? Please remember order of operations here. What do you do first? And then exponents. So we do our exponents. What's -2 squared? 4. But there is a negative on the outside. So it's actually a -4. And then when we do this out, we'll get what?
-10.
A -10, because we will multiply 3 and -2 to get a -6. So the image, the y value, when x is -2, is -2. I want you guys to do B. Find f of 1. Find f of 1. What do you get?
2.
You get 2. Show that point 4, -4 lies on the graph of f. How do you show that? Yes?
y equals f of 4 equals -4 squared plus 3 times 4. Which is then simplified into y equals -16 plus 12. Which then becomes y equals -4.
Questions? Remember, it's the algebraic process to get to that point. All right? Look at the next example. I want you to do the next example on your own. So you have to write down the value of v of 1. You're given a graph that's v of t equals -3t plus 6. T is your what? What's another word for t? Like your x, your input, your independent variable. Then v of t is your
Y.
y, or your output. So need to do what?
Plug in 1 for T.
Plug in 1 for T. And we get 3. So my output is 3. If I plug in 1, I get out 3. I do a similar process here, except this time I'm plugging in 3 to get -3. Good stuff. Now, we could also look at the graph and figure this out as well, since the graph was given to us. When x is 1, what's the point on the graph? It's right there at 3. We look at +3, as we see, -3. You can also go that way. Now it says the point M9 lies on the graph. Find the value of M. How do you guys figure this out? You can look at the graph for sure. Except this time you're going to where y is 9 and you're looking for your x value this time. So when y is 9, x is -1. You can also figure this out algebraically by doing what? Plugging in 9 for y and solving for t. Or actually, m. Subtract 6 from both sides. Divide by -3. And that's how you get -1. C. Find the value of t for which v of t equals 0. What is that saying? V of t equals 0. You're finding the x-intercept. Because if v of t equals 0, that's basically saying y is 0. When y is 0, t is what? T is 2. Look at the graph. You see it right there. You can also get it by setting this equal to 0 and solving. Okay? And the last one, find the set of values for t which v of t is less than 0. What's that saying? What's that mean?
It means that when your dependent variable is less than 0, find every x that matches that and put it in the set.
Okay, exactly. When your dependent variable, when your y is less than 0, find the x's that match that. Okay? Well, when y is less than 0, which means I'm looking at this part and everything below. What x values match that? 2, 3, 4. Anything greater than, it wouldn't be equal to 2. And the reason why is because you're looking for everything that is less than 0.
Oh, yeah.
So it's everything less than 2. I'm sorry, greater than 2. Question on that? Alright. We got one more on you. Giving you 6 minutes. So you're going to draw the graph. Did this graph, what did it look like?
Like that.
Going down.
Describe what going down, so it looked like a what?
Descending.
Diagonal line going right down.
A diagonal line going down, and it crossed the y-axis where?
1 and 1/2.
1 and 1/2 or 1/2?
1.5.
1.5, and the x-axis where? 4.5? 1.5.
No? Wait, 3? Yeah, 3.
It was 3.5?
You were looking
Okay.
probably down.
How you know it's going to the right direction?
So it's negative.
What's going on?
Oh,
Oh.
So it's 3.5?
Yeah, I was doing -0.5 over 0.52, etc.
So it would look like this. This is part A, okay? You only need 2 points to draw a line, okay? And more specifically, why not have the x-intercept and the y-intercept? And that's really all you need. And plus, it asks you to find the point A where the graph meets the x-axis, so that point is...
Wait, is 0?
Okay. Is it 1.5? Is it 3.5? Is it 3? Is it 102?
It's three, it's
Which
three.
one is
It's
it?
three.
I did it on the calculator.
I did it on the
Three.
table. But it's a table graph thing.
Are you sure? Because I'm recording right now.
I'm positive.
Yes, when x is 3, y is 0.
Okay, so A is 3, 0. That's the point where it meets the x-axis. I think. What's the y-intercept?
0, 1.5.
0, 1.5. Good. Now it's asking you, solve the equation f of x equals 2. It's asking you when y is 2, what is x? That's what it's asking you to solve the equation. I mean, you could also,
You just do it algebraically.
oh yeah, you can do it multiple ways. You can do it graphically, algebraically, plug in. Wait,
I don't think.
I say I don't trust you, I don't trust y'all as a whole. So we're gonna solve this out all together. What do we do here? How do we solve for x?
Well, first you distribute.
You can distribute. Okay, so then what's half of 3? 1.5 minus 0.5x. Now what? Subtract 1.5. What's 2 minus 1.5? Equals. Divide by a negative 0.5 and you'll get negative 1. Sure?
99%.
I am sure.
So basically, when y is 2, x is a negative 1. Questions? Alright. Now, functions are used to describe real life situations. The one thing that you guys, or the 3 things that you want to make sure that you do is you want to translate the situation into mathematical language and symbols, meaning variables, numbers, make an equation, find the solution using mathematics, multiplying, adding, subtracting, etc. And then, of course, interpret the solution in the context of the problem. So, in relationship to this problem, what does the solution mean? Okay? So, we have a rectangular piece of cardboard measures 20 centimeters by 10 centimeters. Squares of length x centimeters are cut from each corner. The remaining card is then folded to make an open box. Write a function to model the volume of the box. So, a lot of times when you have word problems, it might be helpful to draw a picture to represent this, okay? Especially since we're not given any type of equation or anything like that. We have to write that ourselves. So, we need a rectangular piece that is 20 centimeters by 10 centimeters. Simple enough. If you switch to 20 and 10, will it make a difference? No. Because we're talking about volume here of a box. Now it says squares of length x are cut from each corner. Can everybody understand what that means? Like if you had a piece of cardboard yourself and you had to cut x length, whatever, of squares from each corner, how would that look like? Like I would take the scissors and I would go to the corner and then I would do what? Cut up
And then towards the end.
and cut over. So basically I'm making a cut like this. Yeah, so this is going to basically look like an elongated plus. So I'm cutting corners, and each of them have a length of x. Everybody following? All right. Now, since the remaining card is folded to make an open box, because if I cut off those corners, I'm able to fold up the 2 sides, fold up the other 2 sides, and it's going to make a box where those 2 edges are going to touch each other. Okay? Write a function to model the volume of the box. Volume, we just talked about it. Volume of a box is what? What times what? Length times width times height. What's the length of your box?
20.
No, we cut the corners.
Remember, you cut the corners.
It's 2x. Or
So when you cut the corners off, technically, you're only left with 20 minus 2x. Whatever x is, you cut off 2 of them. So 20 minus whatever the length of x was, times 2. So my length is 20 minus 2x. my width? 10 minus 2x. Remember, we cut off 2 of those x's, so 10 minus 2x. What's the height? X. Because remember, once we already cut them off and we folded it up, that length represents the height of the box. And there's your model. B equals.
We have like problems where you just have to make models.
But then a lot of times you have to make the model and then do something with that model. Okay? Real quick, just to make sure. X represents what? True. Very good. I'll rephrase that question. In the sense of this problem, we use the variable x to represent what? Which also represented the what?
The height.
The height. Remember, it represented the height of the box. Remember, that's what we plugged in for h. So if you ever had to use this to solve later on, when you solve for x, you would be finding the height of the box. Okay? All of it with respect to the volume.